For this video, we are going to directly talk about KSP. That means that we have an equilibrium that's associated with a solubility product. Generically speaking, the solid, the precipitate that would form, is always going to be on your left side of your KSP reaction. So for example, if we looked at calcium fluoride in the solubility table, it would tell us that it is insoluble. And if we were to write a KSP equation for it, we would have calcium fluoride on the left side as a solid. Again, very little of it will actually come into solution as ions. So we have a double arrow, hence KSP, because it's an equilibrium of the solubility product. We would have calcium ions floating around, and we would have fluoride ions floating around, very few of them. And then, of course, we'd have a KSP associated with that. And that KSP would be based on the reaction, just like we've normally seen. And so it'd be products of reactants. So we have calcium, and it's a concentration since it's aqueous. And we have fluoride, and it's squared because of the 2 moles of fluoride there in the product side. And then, of course, the calcium fluoride would go in as 1 because it's a solid. So we generally wouldn't show that number 1. So I'm just going to show it as such. And then we could look at a solubility chart, or I mean, not a solubility chart, but rather a KSP table, and we could find out what the KSP is for calcium fluoride. So we would go to a table of KSP values to find that. So what exactly can we determine from KSP? One of the things that we can determine from KSP is solubility of calcium fluoride. And the solubility of calcium fluoride tells me the amount in mass of calcium fluoride that is soluble in 1 liter. If I'm below that number, so whatever that number is that we were to determine, if I'm below that number, and I believe for this one it's 0.017 grams, if I'm below that number, I have no precipitate. If I'm above that number and I'm in 1 liter of solvent water, then you will see a solid form. So it gives us an idea of what the limit of solubility is. And we can find that in order to get to solubility, the first thing that we have to find for my chart is an equilibrium concentration of calcium or an equilibrium concentration of the fluoride. The equilibrium concentration would be in molar units, so moles per liter of my calcium, for example. And then I could convert that, knowing that for every 1 mole of calcium, I have 1 mole of calcium fluoride. And so from that, I can go to moles of calcium fluoride. And then, of course, you can go to mass of calcium fluoride through a periodic table conversion. So you must have equilibrium concentrations. And so what that means is we've got to go to our KSP equation up here, and we've got to set up a chart. And so that chart is going to be based off of, we have nothing to start with, we have plus x and plus 2x, and so forth. And you would solve for x, and that would get you to solubility. That is essentially what KSP means and what we can determine from the KSP. In addition, you can also go, if you are given, so for example, another thing that you can do is if you're given the solubility of, let's say, calcium fluoride, and so let's say we're told 0.017 grams of calcium fluoride is soluble in 1 liter of water. We can use that solubility because it's based on equilibrium concentrations and then calculate. We can actually get to the equilibrium concentration of calcium. We can also from it get to the equilibrium concentration of fluoride, and as a result, that tells me that because my KSP is based on equilibrium concentration values, I can actually find KSP. So if you're given the solubility, it will allow you to derive a KSP. You can determine that because we can get from mass of calcium fluoride to moles of calcium fluoride per liter to moles of calcium per liter. And that would be my equilibrium concentration. And likewise, for the fluoride, you could also do the same, and that will get you to KSP. So brief recap, here is my KSP up here. This is the KSP equation. From that equation, when I set up my ice chart, as you can see right here, I've started, you can get to an X value, which will get you to the solubility of calcium fluoride. So once you find X, which would be equal to your calcium ion concentration at equilibrium, you can take that and get to mass of calcium fluoride that is soluble in 1 liter of water. So KSP, ice table, gets you to the solubility of calcium fluoride. Solubility is always in grams per liter. Molar solubility is in moles per liter. Second part, if you're given the reverse, if you're given the solubility, then for the solubility, you can get from solubility to KSP.